Miraculin is a glycoprotein derived from the fruit Syncypalum dulcificum. It is commonly known as the miracle fruit. This fruit is an evergreen plant that grows red berries, and it is native to West Africa. Miraculin is made up of the following sugars: 31% glucosamine, 30% mannose, 22% fucose, 10% xylose, and 7% galactose. Miraculin is made up of 191 amino acids, 7 cysteine residues, as well as carbohydrate chains. Miraculin is a tetramer, which is 4 monomers. They are grouped together as dimers.
To understand how Miraculin works, we must first understand how our tongue detects flavors. Our tongues are full of taste buds, which act as receptors that turn food chemicals into electrical signals. These signals tell our brain what we are eating. Each taste bud has a multitude of cells with proteins that bind to certain food molecules. These interactions between the cell proteins and our food is how we detect flavors, like sweet, sour, and bitter. When a sour food enters your mouth, such as a lemon, the respective sour receptors on your taste buds are stimulated. The lower the pH of a food, the more sour it will taste. Likewise, eating a sweet food stimulates the sweet receptors, which makes us taste sweet. When Miraculin enters your mouth, the protein from the fruit binds to specific parts of your sweetness receptors. Under neutral pH conditions, Miraculin blocks the receptors, which prevents them from sensing sweet flavors in the food. This is why the Miraculin fruit has little taste. When we eat sour foods, the lowered pH causes Miraculin to change its molecular shape. Some of the amino acids in the Miraculin protein that are important to the shape shifting are histidines. Histidines can act as an acid or a base and gain protons in these acidic conditions. This gain of protons changes the charge of the molecule, which thereby changes the shape of the Miraculin protein. This increases the intensity of its binding power, therefore changing the shape of the sweet receptors, making them send stronger signals to the brain. This bond is 100 million times stronger than sugar, making the sweet taste almost unbearable.
About 1.5 million people are diagnosed each year with diabetes. As of 2017, CDC Centers of Disease Control and Prevention estimated about 30.3 million people in the U.S. have diabetes, which makes up 9.4% of the U.S. population, making diabetes the 7th leading cause of death in the U.S. as of 2015. People who have this disorder go through many tedious processes each and every day, whether it be taking insulin shots or managing sugar that comes in the body. Diabetics must control sugar intake in order to maintain and regulate their glucose levels. Most people who have diabetes will admit they have trouble refraining from sugar. For instance, my grandmother, who was diagnosed with diabetes a couple years ago, could drink about 4 to 5 12-ounce bottles of Pepsi each day. Miracle berries could in fact alleviate their situation and aid in not only healthier eating, but also to satisfy said sugar cravings. Miraculin, that is produced in miracle berries, allow diabetics to eat low sugary foods while also tasting sweet flavors without actually consuming any sugars. Lucas Browers, a writer for Scientific American, once wrote, "It is easy to take the way we perceive our environment for granted, but even small protein like Miraculin can turn our senses on their head. This all goes to show how much we depend on our proteins that form our cells and the molecules that cross our way."
Oh! Ow, it burns, but it's sweet.
That's not fun. It tastes sweet, but it hurts.
It's like bread and butter. I don't like that. Like, it's weird, but I'm not mad. Yeah, it tastes different.
That's like the better version of itself.
Tastes like an onion.
Yeah. Ow.